Waveguide Junctions, Magic T, series on microwave engineering, lecture number 1.16. Magic T is a 4-port microwave junction. Structurally, it can be considered as a combination of H plane T and E plane T. Behavior wise also, its properties can be traced back to H plane T and E plane T. Like any other microwave junction, magic tees are also used to divide wave or to combine waves. Here one aspect requires to be mentioned. For the sake of academic definition, we say junctions are capable of dividing a wave into two or more parts. But in practice, it is always in two parts. H plane T divides wave into two parts. E plane 2. Magic T also divides, used to divide a wave into two parts. Directional coupler or rat race. So in practice, all the junctions or almost all the junctions, their outputs are 2 in number, not more than 2. Another aspect is, even though, again for definition's sake, we say junctions are capable of combining waves, but in practice, they are rarely, very, very rarely, nearly never used for this purpose, for combining the waves. Reason is, combining waves is associated with issue related to their phases. To add two waves is not so simple as dividing a wave into two. Addition doesn't take place properly, appropriately, unless the phases of the waves that are being added are appropriately adjusted before being fed to the combiner. So in reality, what microwave junction does is splitting a wave into two. As already mentioned, Magic T is a 4-port junction. It splits the wave into two equal halves and it is capable of giving in-phase outputs as well as out-of-phase outputs. There is magic in its name. Why it is called Magic T? Reason is, there is an element of surprise. There is an element which goes against common sense. There is an element which is beyond our expectation in the functioning of this device. For this reason, it is called Magic T. Other names are also there for this device. All these aspects, some other interesting aspects are going to be discussed in the present session. Main focus is on the structural features, the properties and applications of the device in microwave communication systems. Let us move further into core of the session. A few words, a few introductory words regarding Magic T before going to the real content that describes the Magic T. Magic T is an important 4-port, 4-arm microwave junction. It is used at microwave frequencies, that's why it is microwave device. It is used to divide power or combine powers, microwave powers. That's why it is junction. It has 4 ports, it has 4 arms. It is formed by attaching 2 side arms to the slots cut in the narrow wall and broader wall of a waveguide piece. The device was originally developed by W.A. Terrell of Bell Labs and published it in an IRE paper in 1947. Robert L. Kyle and Bob Dick also contributed for its development independently during World War II. It is called different names: 3dB hybrid, 3dB coupler, anti-symmetric coupler. 2 more names are also there: EHT and hybrid T. These are all names for this device, but Its most popular name is MagicTee. The arm connected to the slot in the broader wall is called E-arm or series arm or difference arm, and the arm connected to the slot in the narrow wall is called H-arm, parallel arm, or sum arm. Here he is describing the structure of the device. 3 pieces of rectangular waveguides are required to fabricate a MagicTee. Consider one piece. This is a piece of rectangular waveguide. Now make 2 slots, one in side wall here. Remove the material, a hole appears here, and attach a piece of rectangular waveguide covering this entire hole like this. Now you can see it is actually H-plane T as it is. This arm is called H-arm, parallel arm, or sum arm. Next, what we need to do is make a slot in the broader wall and remove the material. A hole is there, a slot is there. Now here, take another piece of rectangular waveguide and attach to the broader wall, and see that this piece covers the entire slot, entire hole in the broader wall. This piece is known as E-arm or series arm or difference arm. The entire structure, total structure minus H-arm is E-plane T. Now one can see both H-plane T and E-plane T in the structure of MagicTee. The structure and symbol are given here in pictures along with electrical properties of the device. In A, the structure along with port numbering is shown. Arm 1, arm 2, these are collinear arms. Arm 3, arm 4, these are side arms. Collinear arm ports are designated as 1 and 2, whereas H-plane arm port is designated with 4. Other port is designated with 3. The H-plane arm is also called arm P. Here P stands for parallel. E-plane arm is also called arm S. Here S stands for series. There is a symbol for this device, a horizontal straight line, a vertical straight line, and a line with a slanting angle. Horizontal straight line, it denotes both the collinear arms. Their ports numbering is also shown in the symbol. Note, symbol is a symbol only when it contains port numbering. Otherwise, it is not at all a symbol. H-arm or sum arm port is given number 4. E-arm or difference arm port is given number 3. In C and D, the behavior of the device, the electrical nature of the device, the properties of the device, they are explained. In typical application of this device, input source is connected either to port 4 or port 3. When source is connected to port 4, the output of the source is divided into 2 equal parts, and those parts appear at ports 1 and 2, and nothing appears at port 3. This is the magic. When source is connected to port 3, the output of the source gets divided into 2 equal halves, and they appear at ports 1 and 2. Nothing appears at port 4. This is magic. If input is at port 4, nothing out of the input appears at port 3, and input is at port 3, nothing out of the source appears at port 4. It is against common sense. It is an element of surprise. This aspect, this element in the behavior of the device led to calling the device, naming the device as MagicTee. This can be understood, or this aspect can be explained with the help of flux line representation of the wave. In C, a situation is depicted where source is connected at port 4. So, if this is port 4, if the wave is in dominant mode input wave, then electric vector will be vertical. It may be upwards or it may be downwards. In one half cycle, if it is upwards, in the other half cycle, it will be downwards. Anyway, we are considering an instant where electric vector is upwards. So the wave with its electric vector upwards, it travel, reaches the junction, and it gets split into two parts. One part traveling towards port 2, another part towards port 1. The field direction in coplanar arms is indicated upwards, same as the direction of the field in the input wave. Now the point is why the input wave, even a small part of it, didn't enter into E arm or difference arm. Here in the diagram, no field lines are shown, no flux lines are given. They are absent in E arm or difference arm. It implies wave is absent. Then why input wave is unable to enter into this arm? Reason is this: wave has a structure, guide has a structure. If the guide of the structure is compatible to the structure of the wave, then only wave can exist in that guide. Then only wave can travel through the guide. In the input wave, electric vector is vertical. Broader wall is there at the bottom, another broader wall is there at the top. These two walls support the electric vector. This is a feature of the input wave. Electric vector vertical supported by two conducting walls. For this wave to exist in this arm, there must be two conducting walls and capable of supporting this structure. But where are the walls? There are no horizontal walls. Walls are there. This is also a piece of rectangular waveguide. It has four walls. All are vertical. No wall is horizontal. But to support the wave that is given as input to the device, horizontal walls are in the E arm or difference arm. So this wave, input wave, cannot exist in E arm. So output at port 3 is 0. This fact can be explained in some other ways too, but simplest way of explanation is given here. Now let us come to D. Here the situation where input is connected to port 3 is depicted. When the wave, input wave, is in dominant mode, electric vector in it points from one broader wall to another broader wall. Here it can be from left to right or right to left. A situation is considered where an instant is considered where electric vector is from left to right. Now the wave travels through the E arm, reaches the junction region. Here it gets split into two parts. One part moving towards port 1, another part moving towards port 2. But nothing enters into H arm or some arm. Why? Reason is the same. Wave has a structure. Guide has a structure. When these two structures are compatible, suitable to each other, then only wave can exist, wave can enter, wave can travel through the guide. The wave in E arm, it has a structure which is not compatible to the structure of the H arm guide. So this wave cannot enter into H arm. So output at port 4 is 0. Before going further, notice when input is at port 3, the outputs are out of phase. At port 1, electric vector is pointing downwards. At port 2, it is pointing upwards. It implies that outputs are out of phase. When the input is at port 4, as depicted in C, the outputs are in phase. You can notice the electric vectors at port 1 and port 2, they are pointing in the same direction. It implies in phase relation between the outputs. Now, we move further in understanding the structure and behavior of the device in words. The collinear arms are usually equal in length and their ports are usually designated as 1 and 2. Side arm ports are designated as 3 and 4. However, there is no unique established convention regarding the port numbering of this device. MagicTee is basically a hybrid in which the power is divided equally between the output ports. The outputs exhibit either 0 or 180 degrees phase difference depending upon the source location. In typical application of MagicTee as power divider, the source is connected to one of the sidearm ports with matched termination at the other sidearm port. The load impedances are connected to the ports of collinear arms. Here in this diagram, the functioning of MagicTee as power divider is described. As already mentioned, source is connected either at port 4 or port 3. Here in this diagram, source is connected at port 4. Let us suppose amplitude of the wave that is injected into port 4 is A4. The wave then travels towards the junction, enter into the junction. There it gets divided into two equal parts. One wave traveling towards port 1, another wave traveling towards port 2. Amplitudes of these two waves, they are equal to A4 by root 2, A4 by root 2. These two waves then fall over Z1. Z1 is the terminating impedance at port 1. Z2 is terminating impedance of port 2. If Z1 and Z2 they are equal to characteristic impedances of the arms, then everything that is incident over them gets absorbed. Otherwise, reflections takes place. Usually, the arms of the device they are made with the same or from the same waveguide. So their characteristic impedances are same. Let us say it is Z0. As Z1 is different from Z0, then reflections happen from Z0. Similarly, Z2 is different from Z0 and hence reflections happen from Z2. So the result of incidence of a wave whose amplitude is A4 by root 2 over Z1 is partly this wave goes into the impedance, partly it gets reflected. The reflected wave amplitude is equal to gamma 1 A4 by root 2. Similarly, a wave gets reflected from impedance Z2. Its amplitude is gamma 2 A4 by root 2. Here gamma 1, gamma 2 are reflection quotients. They are equal to Z1 minus Z0 by Z1 plus Z0. This is gamma 1. Gamma 2 is Z2 minus Z0 by Z2 plus Z0. Anyway, two reflected waves come into being and they travel towards the junction region. Here, these two waves get split into two, resulting in a total of four waves. Two waves traveling towards port 4, two waves traveling towards port 3. These two waves then combine to give a wave whose amplitude is equal to B3 at port 3. Notice here combination doesn't mean addition, it is subtraction. Whereas the two waves that are traveling towards port 4, they combine giving a wave whose amplitude is P4. Here combining or combination means addition. At port 3 it is subtraction, differencing. At port 4 it is addition or summation. That is why arm 3 is called difference arm. Arm 4 is called sum arm. The story doesn't end here. At port 3, if the termination is matched, then entire incident wave gets absorbed. Otherwise, partly it gets reflected. Now, another wave A3 with amplitude A3 comes into being. Now it travels towards the junction. Again, it gets split into two parts. One part traveling towards Z1, another part towards Z2. There again, two reflected waves get generated. They reach junction. There another four waves come into being. So ultimately, multiple reflections occur in the device. This is possible, of course, only when load is mismatched or source is mismatched or both are mismatched. Some more points regarding the behavior of the device. It exhibits the same behavior when the terminations are interchanged between side arm ports and collinear ports. For correct functioning, this device must have an internal load matching structure. This arrangement usually consists of an inductive iris inside the E-plane arm and a post inside the H-plane T. However, several alternative structures have been proposed, but using the matching structure implies that the device performance is satisfactory only over a limited frequency band. Now, some interesting and useful properties of MagicTee. Under ideal conditions, all ports are perfectly matched to the junction. So this is MagicTee. All ports match to the junction means if you connect a source here, then the output of the source goes totally into the junction and nothing gets reflected back towards the source. This is the situation with all ports in MagicTee device. Of course, this is under ideal condition. The E and H arm ports are decoupled, as are the coplanar arm ports. In reality, the isolation between the side arm ports is broadband in nature and is as perfect as is the symmetry of the device. The isolation between the collinear ports, however, is limited by the performance of matching structure. Side arm ports are isolated means if you give input here, nothing out of it appears at the other side arm port. Collinear arm ports isolated implies if you give input at one of the collinear arm ports, nothing out of it appears at the other collinear arm port. So perfect isolation exists between collinear arm ports. But this is the situation when the device is a perfect one, an ideal one. Now, a few points regarding the functioning of the device as splitter. A signal into any coplanar arm splits equally between E and H arms. For each output signal, the amplitude and powers are A by root 2 and P by 2 respectively. Here A and P are amplitude and powers of the input signal. We know very well that power is proportional to amplitude of the signal. A signal into H arm splits equally between the coplanar arms, the outputs being in phase when its collinear arm lengths are same or differ by integral number of wavelengths. Out of phase. Outputs are out of phase if collinear arm lengths differ by an odd number of half wavelengths. A signal into E arm splits equally between the collinear arms, the outputs being out of phase when its collinear arm lengths are same or differ by integral number of wavelengths. They are in phase if the collinear arm lengths differ by an odd number of half-wave lengths. These aspects give tremendous insight into the functioning, into the physics, into the behavior of the device. The MagicTee can also be used to combine two signals. In this application, usually sources are connected at coplanar arm ports. For signals into both coplanar arms, the signal amplitude of output from the E arm equals 1 by root 2 times the phasor difference of the input signals. That's why it is called difference arm. The signal amplitude of output from H arm equals to 1 by root 2 times the phasor sum of the input signals. That's why H arm is called sum arm. Some are aspects of the device as combiner. For signals into both side arms, the signal amplitude of output from one of coplanar arm equals 1 by root 2 times the phasor difference of the input signals, and the signal amplitude of output from the other coplanar arm equals 1 by root 2 times the phasor sum of the input signals. The difference signal appears at port 1 and the summed signal appears at port 2 when electric vector at E arm port is towards port 2. The summed signal appears at port 1 and difference signal appears at port 2 when the electric vector at E arm port is towards port 1. So far, we considered the structure and properties, behavior of the device. Now, it is the time to consider the applications of MagicTee. The device is widely used as a tuner, as duplexer, and as mixer. It is also useful in the measurement of impedance. These are some of the applications. Some more applications are also there for MagicTee. In due course of time, they are all introduced. Here in this slide, the functioning of MagicTee as a tuner and as duplexer. It is described. A source of signal is connected at port 1, load is connected at port 2. If the load is not matched, then reflections happen. The reflected wave may enter into the source, disturbing the functioning of the source, the performance of the source. So it should be arranged in such a way that reflected wave do not come into being. Here an arrangement is given. In this arrangement, two movable shots, they are inserted into side arm ports, and by moving these shots into and outside in the arms, the susceptance of the junction can be varied. By moving the shots, we can have different amounts of susceptances connected across the junction in the path of the signal. The susceptance then can be adjusted so that the load or source that is connected at port 2 is matched to the source. Then there won't be any reflections. There won't be any danger of disturbing the source performance. In diagram B, the use of MagicTee in duplexer assemblies is shown, illustrated. Before going to the description of this circuit, one must know what is duplexer. In a typical communication, wireless communication systems, one antenna is used at the transmitter, another antenna is used at the receiver. Antenna at the transmitter is meant for transmitting the signal. Antenna at the receiver is meant for receiving the signal. Usually, transmitter and receiver, they are at great distances. So, two antennas are necessarily required to be used for the functioning of communication link. But in radar systems, transmitter as well as receiver both are in the same premises. Both the antennas are near to each other. Most of the times, they may be even side by side. In such situations, it is possible to use a single antenna both for transmission as well as reception, making the entire system less expensive. Duplexer is a circuit. Duplexer is a subsystem which is useful in making a single antenna useful both for transmission as well as reception. MagicTees are widely used in duplexer assemblies. A typical arrangement of duplexer is shown in diagram B. Transmitter is connected to H arm port. Receiver is connected to E arm port. Side arm ports are isolated from each other. Therefore, one can notice the existence of perfect isolation between transmitter and receiver. The transmitter output can never reach the receiver. Receiver is isolated from transmitter. And matched load antenna, these are connected to collinear arm ports. When transmitter is working, the output of the transmitter enters into the junction region. It gets split into two parts, one part entering into the antenna. From there, it gets radiated. So half of the transmitter output gets radiated. It goes into space. Remaining half, of course, it enters into matched load. There it gets dissipated. Nothing out of or output of the transmitter goes to receiver. This is the situation when the system is transmitting. When it is receiving, when antenna is being used for receiving, the output of the antenna, it travels towards the junction. There it gets split into two parts, one part towards the receiver, remaining part towards the transmitter. The part that goes to receiver, it enters into the receiver and it gets processed further to extract information. The part that moves towards the transmitter, it enters into the transmitter, it gets absorbed there. Usually the output of the antenna when it is in receiving mode is quite small. So the wave that enters into transmitter, it is so small that in fact we need not consider its presence. So this is the way single antenna is used with the help of duplexers for both transmission as well as reception. Now description of the applications in words. EHF tuner. It consists of a hybridity and a pair of adjustable short circuits. The series reactance value Xs is controlled by Ls, while the shunt reactance value Xp is controlled by Lp. Here Ls, Lp, these are distances moved by the shorts. Practically, any load impedance can be matched by the EHF tuner since Xs and Xp are independently adjustable to any positive or negative value. A few words regarding duplexer. A duplexer is a three-port network that allows a single antenna to both transmit and receive EM signals while protecting the sensitive receiver from the transmitter tower. A MagicTee version of the duplexer is with a continuous wave source connected to port 4 H arm port and a receiver to port 3 E arm port. The common antenna is connected to one coplanar arm and a matched load to other. The operation of the duplexer follows directly from the properties of 3dB hybrid. A continuous wave signal into port 4 splits equally between ports 1 and 2. Assuming perfectly matched components, half of the source power is absorbed by the matched load and the other half is radiated by the antenna. But none of the transmitter power appears at the receiver port. This is important since even a few milliwatts of power can permanently damage the receiver. At the same time, any signal received by the antenna splits between the E and H arms, with half being delivered to the receiver at port 2. Thus, this system allows the simultaneous transmission and reception of microwave signals, but using a single antenna. Another application of MagicTee is as mixer in communication receivers. The local oscillator is connected to one side arm and the receiving antenna to the other side arm. One collinear arm port is match terminated and to the other mixer circuit is connected. The local oscillator output and antenna output get multiplied in the mixer circuit, giving out IF output for further processing by the receiver. Now, typical specifications of this device. Frequency range is given in the specifications. Here it is 33 to 50 gigahertz. Waveguide size is given. Here it is WR22. Insertion loss is given. Isolation is given. VSWR max in H arm and in E arm they are given. Balance is given. Operation bandwidth is given. These are all the information that is available in the specifications of Magic Tea. This is what I have to share with you for right now. To recap, Magic Tea is introduced along with its structure and properties. A few important applications of Magic Tea are also described. Hope you have a wonderful and beautiful, a fruitful and successful and enriching learning experience. Enough for now. See you soon again. Bye bye.